This is CPM Precalculus, Chapter 1, number 114. Harold, the happy concrete guy, got a call on the phone about some concrete he has to pour for an odd-shaped triangular patio. So the triangular patio looked something like this. The only information he got was that the side lengths were 5, 6, and 8 meters long. Okay, so this is his patio, part A. Part A, we're asked to find the angles for Harold so he can stay happy. Okay, so we need to find the angle measurements. Okay, so here's our triangle. Let's label it so we can reference these things. So let's just say ABC, triangle ABC. If this is angle A, we know across from angle A, it opens up to side A. So let's just give these sides names as well. Across from angle B, this angle opens up to side little b. And across from angle C, this side opens up to little c. Okay, so now that we have named it, we need to find angles A, B, and C. So let's go ahead and do this. So remember that when we're given just the sides, and this is not a right triangle, or we don't know. Well, actually, yeah, we know it's not because of the side lengths. How do we find the angles? Well, if we know all of the sides, we can use the law of cosines. Right? The law of cosines is basically given triangle ABC, right? Similar to this, we know that c squared is equal to a squared plus b squared minus 2ab times cosine of angle C. Okay, so these are all little c, little a, little b, little a, little b, and this is the angle C. Okay, similarly, we know that we can find b squared by, so the little memory technique is c squared equals a squared plus b squared minus 2ab cosine C. So this C, this little c here, is big C there. So this little b here is going to be a big B there. So instead of A and B, we're going to have A and C, right? AB minus 2AB, so it's going to be AC minus 2AC cosine big B. And likewise, B squared plus C squared minus 2BC times cosine of angle A. So this is the law of cosines. Okay, and we're going to use this law to find angles A, B, and C. So let's start off by looking for angle A. For that one, we're going to use this formula because this one has angle A in it, and we know little a, little b, little c. Okay, so we're going to start here. A squared equals b squared plus c squared minus 2bc cosine angle A. Okay, so we're going to try and solve this equation for angle A. We want A equals to something, so we're going to isolate angle A. So first of all, let's subtract b squared and c squared from both sides. So we get a squared minus b squared minus c squared on the left, and on the right we just have negative 2b cosine, 2bc times cosine angle A. Then let's divide both sides by negative 2bc. So we get a squared minus b squared minus c squared divided by negative 2bc equals to cosine of A. And if we can't divide by cosine because cosine is wrapping A. So we need to unwrap it with the inverse cosine, right? So if we unwrap on the right, we have to unwrap on the left with the same thing. So the inverse cosine cancels out with the cosine, and we get A on the right, and we have this on the left. So let's substitute in A, B, and C. So we know A is 8, so we get 8 squared is 64, 8 times A is 64, minus B squared, so B is 6, 6 times 6 is 36, minus C squared, 5 times 5 is 25, divided by negative 2 times B is 6, and C is 5. Okay? So 64 minus 36 minus 25 is 3. 2 times 6 times 5 is going to be, since it's negative, it's going to be negative 60. Okay, so that's what A is equal. We can simplify this even more, right? Because we know 60 divided by 3 is 20, so this is going to be the inverse cosine of 1 divided by negative 20. Okay, let's bring out our calculator. Let me turn this on. And we just do the inverse cosine of 1 divided by negative 20. And we get 92.86598398. So we get A is approximately 92 point, and let's round to 2 decimal places. So this 5 is going to round the 6 up to 87 degrees. Okay, so let's write that in here. Angle A is equal to 92.87 degrees. Okay, or you could say it's approximately, because that's what it is. Okay, so similarly, let's find angle B. Now we use this equation, right? This law of cosines equation, because we know B, A, and C, and we just want to find angle B. Okay, so we can, again, we solve this equation for angle big B. Okay, so we subtract A squared and C squared over, and then divide by negative 2AC, and then take the inverse cosine. So we're going to get the inverse cosine of B squared minus A squared minus C squared divided by negative 2AC equals to B. Okay, so I did all this right here in one step, but go ahead and take your time and show all the work. When you're really comfortable, you can skip steps. Okay, so then let's plug these in. B squared, so let me move back so I can see what B is. B is 6, so it's 36, minus A squared is 8, so minus 64, minus C squared is 25, divided by negative 2 times A is 8, and C is 5. Okay, so 36 minus 64 minus 25 is negative 53. 2 times 8 times 5 is 80. So that's negative 80 because it's negative. Okay? And remember that a negative divided by negative is a positive. So these both cancel out and they become positive 53 over 80. So let's now do the inverse cosine of 53 divided by 80. Okay? And we get 48.50918314. So if we round to 2 decimal places, this 9 makes the 0 into a 1. So B is approximately 48.51 degrees. Okay, so let's put it up here. B is approximately 48.51 degrees. So finally, we want to find angle C. We can use this equation here to find angle C. Or since we know angles A and B already, we can do a shortcut to find angle C. The shortcut is, given any triangle, when you add up all 3 triangles, the sum of the 3 angles in a triangle is going to be 180 degrees. This is always true no matter what the triangle looks like. Okay, so angle A we found was over here is 92.87. Angle B is 48.51. Angle C, I'll leave like that, is equal to 180 degrees. Okay, 92.87 plus 48.51 is 141.38 plus angle C is equal to 180. Now 180 minus 141.38, so subtract this from both sides, we get angle C is equal to 38.38. 38.62 degrees. Okay? And again, we should write it's approximately because when we substitute these in, these are approximate answers. So angle C is approximately 38.62 degrees. Okay, so this is part A. We found all of the angle measurements. Okay, so for part B, we want to find the area, right? Find the area of the patio that Harold is forming. So we want to find the area of this patio here, right? The area of the patio, or we labeled it so we could say triangle ABC. Use different vertices. If you said it was XYZ, well then you're looking for the area of whatever triangle you labeled here. Okay, so the area we know for a triangle is equal to 1/2 base times height, right? Well, looking at the triangle this way, the base is side little a, 8, and the height is going to be this altitude here when we form, let me use a different color, when we form a 90-degree angle with the base, this is the height, right? So how do we find that height? So we know it's going to be 1/2 base is 8. We need to know the height of this triangle or this altitude here. So let's call that H. So if we redraw this triangle over here, let me use the same colors. Right, so we have C, B, and A, and in the middle here we have the height. Oh, I cannot draw H. Okay, and we know the base is 8. So we need to know, so that's 8 meters. We need to know the height. Okay, so how do you find the height? Well, since we know angle C, right, we can look at angle C and our trig identities. So using SOHCAHTOA, right, sine of angle C is equal to the opposite. So if we're looking at just this triangle right here, let me put it in orange. Just this triangle right here, sine of angle C is going to be opposite, which is H, divided by hypotenuse. So what's the hypotenuse of this right triangle? It's going to be this side, and we know that that is 6. Right? This length right here is 6. Okay? And do we know angle C? Yes, we do. Angle C is 38.62 degrees. So sine of 38.62 is equal to H divided by 6. So can we use this right here to solve for H? Yes, if we multiply both sides by 6, right? These cancel out and we're left with H on the right side equals to 6 times sine of 38.62. So let's put that in our calculator. Okay, so we have 6 times sine of 38.62, and we get H is equal to 3.74. Okay, so rounding to 2 digits, again, decimal places. This 4 makes this 4 stay. Okay, so let's get rid of that. So we have H is that. So we know area then is going to be 1/2. Base is 8. H is 3.74. Right? So let's put that in our calculator. 1/2 times, times 8 times 3.74. Okay, so this is going to give us the area, which is 14.96. So that's, let's say approximately, because we are approximating using this angle. So it's approximately 14.96. And since we know all the sides are in meters, so the area is going to be meters squared. Okay, so this right here, 14.96, is the area of triangle ABC. So this ends CPM Precalculus Chapter 1, number 114.